Hello, or good afternoon, everyone. So nice to meet you. So I'm glad to have the opportunity to give the presentation. So I'm thanks for supporting the member of the Zabbix Japan and the Zabbix headquarters. So first, let me introduce ourselves. So my name is Mitsuhiro Ono. I have 20 years experience as a system engineer. I had or have several major cloud certifications. So I was very excited to hear the news about the Zabbix Cloud. So I'll check the Zabbix Cloud when I back to the Japan. So now I work for the Toyota Motor Corporation. I belong to the E3 Computing Group's Infotech IS. It's a researcher group. So research area is computing and communication from the vehicle to the cloud center. So my recent project, advanced development of connected infrastructure for the green mobility, and advanced development of system monitoring with anomaly detections. So let me hand the mic to the Akamatsu-san.
Okay. Hello, guys. My name is Toshihiro Akamatsu. I have 10 years of experience as a system and technical support engineer for OSS, including Zabbix. And my company, SRA OSS, provide OSS-related services, for example, technical support, consulting, and product development and training. This is my third time attending Zabbix Summit, but this is my first time as a speaker. So I'm very happy and excited to be here. Okay, perhaps you guys want to go out for drink already? Yeah? No? Oh, okay, I'm so relieved. So let's get started our presentation.
Thank you. I'm sorry to speak in English well, but I try. So let's begin. For the vehicle company, achieving carbon neutrality is a significant issue for expanding the value of the mobility. In terms of the in-car, we provide a multi-path strategies, meaning we provide several diverse options vehicles, such as battery-based EV and plug-in hybrid EV and hydrogen EV, fuel cell EV, and hydrogen and carbon-neutral fuel-based fuel vehicles. So in terms of the outcome, we provide connected services, which collecting and analyzing car condition and the situation from the car that's connecting with the internet. This allowed us to offer the valuable information for the carbon neutrality, such as energy-saving route guidance. So recently, the volume of the car and data that communicate with the cloud is on the rise. So the increasing the demand of the cloud is expected to reach the significant increase in electricity consumption in the future. So the use of the green energy is essential, as is the conservation of the energy. So what is the issue in the utilizing green energy? There are many types of green energy. There are solar power and the wind and of the hydrogen power. So in this green energy, so solar power is the most widely adopted in the world because its power generation potential is anywhere, and the cost of the solar panel is down year by year. So cost reduction leads to the cheaper electricity. However, solar power generation fluctuates seasonally. Weather affects the electricity generation, so surplus occurs if the production exceeds the demand. So the balancing power supply is hard for the power company only. So what is our action? So to reduce the waste electricity, we are working on control power usage dynamically when surplus is expected. So we are developing a solar power simulator for surplus use. It's a simulator. It's a simulation-based visualization of the power generation potential. Point is when and where and how much. When is several years before simulated. So which is the best place on our site? How much is the potential value with the weather? To develop the solar power simulator, we choose the OSS, so because we can quick and small start, and we have several requirements to developing in the OSS. So first is it have essential dashboard widget to express the time series data depending on the weather. And second is it have an extensive monitoring function and example because we would like to develop the more smoothly and efficiently. And third is it have the active support and the community. It's also we'd like to develop smoothly. So I have already loaded the slides. Zabbix is well suited for our project to developing the solar power simulator. Good. So Zabbix have an essential dashboard widget, like to express the time series data depending on the weather. So we developed the spiral dashboard, and so we discussed which is good or bad. And the second is Zabbix also have the extensive monitoring functions. Yeah, we developed the simulator efficiently. And third, Zabbix have the active support and community like yours. And in our project, SROSS members supporting us. So they provide us for valuable information to developing the solar power simulators. So I say that Zabbix is well suited. So this is our system overview of our project, Green Mobility Project, one of the Green Mobility projects. So it's about an experiment to manage the resources using solar power predictions. So we tried utilizing computer resources during the period and at the location with the surplus energy. In that system, Zabbix is a very key component. It's collecting the simulation data and summarizing and visualizing. Also, it's transferred to the controller. Then the controller component can manage the resources on each side. So I'd like to detail about the Zabbix dashboard for the solar simulator. It's Akamatsu-san.
Yeah. Okay, from here, let's take a look at the solar power simulator details and how does it work with Zabbix. Solar power simulator calculates and outputs current and hourly forecast values for the next 72 hours for global solar generation and electric generation capacity and CO2 reduction and weather. And the data on which the calculations are based is obtained from OpenWeather via API. And then Zabbix retrieves each data using SNMP. And next is Zabbix dashboard for solar power simulator. The data from simulator is visualized using Zabbix dashboard. Zabbix dashboard components as follow: history of solar power generation, and current values of solar radiation, solar power generation, and CO2 reduction. And forecast values of solar power generation of hourly for the next 24 hours, and total for the next 24 hours, and total for the next 72 hours. And weather forecast and location map of each site. So next is dashboard components. First, display of power generation potential. We use top host widget to display electric generating capacity potential for 24 hours and next 72 hours. And using top host widget, we can display the future power generation potential of each site in descending order. So it makes it easier to understand which site has more potential in the future. Next is weather forecast. Weather forecast is displayed also using top host widgets. And the data from simulator is just string data. So we use value mapping. Sorry, this is disappeared.
Yeah. Okay, yeah. I like that.
Yeah, like this icon display here. Yeah, we use value mapping feature and change the string data to iconic display data. So also this makes it much easier to understand visually. And top host widget can be added for sorting. Yeah, this here. And we added column for longitude data and display the forecast weather forecast data in geographically sorting. And next is site-to-site comparison. These widgets is used for site-to-site comparison. For example, to display current value of each site, using gauge widget and display historical and forecast values past 24 hours and next 24 hours using graph widget. This widget can be displayed which sites have more potential and how the current status of each site is to understand. As mentioned before, we made forecast value graph, but to achieve this, we had a bit of difficulty. For example, if you set the graph, the data, as it is, and graph usually display values at the time that values are obtained. But for forecast value graph, we want to display only the latest value. Past value is no need. And also, we want to display forecast value at forecasted time, not at the time data is obtained. To resolve this difficulty, we use the graph widget feature, aggregation and time shift. To display only the latest value, we use aggregation feature. And to display forecasted value at forecasted time, we use time shift feature. Yes, and using this feature, we finally achieved to make forecast value graph successfully. Finally, I want to introduce one of our next challenges, Zabbix and Kafka integration. We are aiming to achieve more flexible and scalable visualization of this simulator. And so we are working on the implementation of Zabbix and Kafka integration. And Zabbix to Kafka, we use Kafka connector, which provides in Zabbix 7.0 to aggregate multiple Zabbix data in Kafka. And Kafka to Zabbix, we use Zabbix API and history push. It's also be available in Zabbix 7.0 to integrating data in Kafka from other Zabbixes. This is intended to provide more flexible and scalable visualization of the simulator. Okay, I'll leave the summary to Ono-san.
Okay. It's a summary. To achieving a sustainable mobility society, so we are working on the utilizing green energy. So Zabbix is suited for a real-time, flexible, and the visualization of the solar power generation status thanks to the latest weather forecast. So we will verify the architecture that utilizing the green energy, including the solar, and next is the wind power. So please next slide. So SROSS booth is here. And we present our dashboard. So if you have a time, please check our Zabbix dashboard. Thank you. That's all.